Okay, welcome, Michelle and Shan, Mary and Sarah, and thanks, Bralia, for coming. Let me jump to my screen share and show you the plan for the day and what today's all about. Okay, so here's the plan. Oh, you know what? I had that from the last class. We're gonna start out with Q&A as always, and then we'll get into sampling distributions. So today is like a major day in terms of really understanding how to look at a survey and decide what you can do with it. Today's the beginning of it, and we're going to be doing that pretty much for the rest of this entire course. So we're going to be looking at sampling distributions today. We're going to look at unbiased and biased estimators. We'll look at central limit theorem for means. We'll look at the central limit theorem for proportions. We'll look at the central limit theorem for sums. And then finally, let me put it in here, and that is exam review. So just a major reminder, and I'll remind you more than once today, is that this is exam week. So you're going to have your exam one, and you can choose between Thursday, Saturday, or Sunday to take it. So whichever works best for you. Don't take it twice. No reason to torture yourself. It's not like you get a better score if you take it twice. So just take it once, and you get to choose. It's a 2-hour exam, and I'll talk a lot about what it's going to be about and what the problems are going to somewhat look like at the last part of today. So that is the plan of the day. I also want to mention that this morning I did a marathon morning from like 5:30 in the morning until around 10. I finished up reading and grading all of the papers, the projects. So some of you did a great job on the project. Some of you did an okay job. Then there's those who didn't turn one in, and that's never good. So it's a mix. I'm here for you. Braulio's here too to help you out, to make sure that, it works out. So you can look at your grade and you'll know where you are. And if you have questions, you can always ask and I'll help you out. But there's a project 2 coming up in a month or so. So you got a while, but still, time creeps up fast. And, you want to do well on project 2. So if you already did great on project 1, keep it up. If you didn't do as well as you'd like to, then, see what you can do to get better. That's the key. So are there any questions about anything before we get into chapter 7? Any questions about anything? Give me a moment. Okay, if there's no questions, then I'll jump into chapter 7, which is a really important chapter. So, don't take it lightly. I do want to let you know that chapter 7 will be covered in exam 2. So, which means it's not going to be covered in exam 1, which is this week's exam. But, don't take this lightly because it's part of the next exam. So next exam covers from chapter 7, 8, and 9, basically, is chapter 7, is the next exam. Whereas this exam is 1 through 6. So just to let you know, I want to ask you something. Is there anything you're interested in, quantitative variable, about each other that we're going to do a survey on? You can pop in the chat box. You can say it, what the survey question might be, or you could ask each other. And it has to be a number, quantitative. Any interest? Take requests. It's always more fun to find out about each other. Okay, how many hours a week do you work? Okay, I'm going to go for I'm going for the first one first. So how many hours a week do you work? Let me type that in. Okay, so all you have to do is say how many you work, and I'm going to put in all the numbers. And let's see, we got 40, 32, 26, 0. By the way, I don't mention names, so there's no reason to be embarrassed, and you don't have to tell the truth, but don't say 1,000 because you can't work 1,000 hours a week. 40, 32, 26. Zero, 32. And maybe I'll put mine in there, but I'm an outlier. I don't know if you know, but I'm a workaholic. Like 50 is about my best guess. I work a lot. I do this. I also have some grants and stuff that I do too. So I'll pop it in. But the good news is I wake up at 5 in the morning, so I can like get a lot done for the first 8 hours of the day when no one's bothering me. So we have a bunch of numbers. Okay, so that's the first question. The next question is, let's see if we can find some important numbers. What are the two most important statistics there are? In this class, at least. This review, you should know this. What are the two biggies for our class? Yeah, standard deviation and mean. So let's find the mean and standard deviation, and I'm going to do it the easy way. I'm just going to pop it into a calculator. And we did get all of us, so I'm going to call this population. Hopefully you all answered. I wasn't paying complete attention, but I'm going to assume. And, oh, nice, easy mean. Mean was 30. Standard deviation was about 14.9. So let's write that down. So the mean is 30. Standard deviation is 14.9. So then what symbol do we use for the mean?
Mu?
Yeah, mu. Okay, so we use mu for the mean. So need to make it a mu looking thing. So mu was 30. And what symbol do we use for the standard deviation?
Sigma?
Sigma. Okay, because we're talking about the population standard deviation. So sigma was 14.9. Had those numbers backwards in my head. 14.9. Okay, so it's very important that you get the symbols down, solid in your head. And I got some bad news for you. The bad news is we're doing more symbols today, and they look similar, and they're said similarly, and they're different. And that's always the hardest. All right, so now I have a next question for you. Okay, not a survey question, but a next task. So what I want you to do now is randomly choose 3 of these numbers. Let me go data values. Okay, and you remember, how do you truly randomly pick 3 numbers? There's only one successful way to do it, or one real way that people do. Yeah, use a computer, or I'm going to actually bend that a little bit, because for some of you, it'll be easier. You could use a smartphone. So you could very easily use your smartphone. So we have 1, 2, 3, 4, 5, 6, 7. So pick 3 numbers from 1 to 7, and then grab the number that was picked. Got it? So I'll even do it on my computer, but you can do it yourselves too. You can ask you just ask Siri or whatever, pick 3 numbers from 1 to 7, and it'll just give you 3 numbers random, or 3 random numbers from 1 to 7. It'll do it. If you talk to your smartphone, it will work. Okay, and pretty much all smartphones can do it. I'm gonna use my calculator because I don't have my smartphone in front of me. I try not to get distracted by smartphones when I'm teaching. But that's number one, random number generator. I need to pick a number from 1 to 7. Gonna get it. I got a 1. Let's get another one. 6, 7. So I got mine were 1, 6, and 7. Okay, you're gonna get different ones. So 1, 6, and 7. So mine are 1, 6, 7, which means 40, comma 32 and 50, comma 50. So I want you to pick 3 numbers. It's very easy to do. You could either use the computer, your smartphone, whatever it takes. Now, then find the mean and the standard deviation of your 3 numbers. So I'll do mine, but I want you to do yours too. It's important. So if I go back to the calculator, I can do one variable stats, pop in the 3 numbers. Is this a population or a sample? Yeah, this is definitely a sample. So we're going to do sample standard deviation, and I hit calculate. Okay. Okay, interesting. I got really big numbers, just random, truly random. The computer did it. And the mean was 40.7 or so. My standard deviation was about 9, almost exactly 9. Nice. So 40.7 and 9. So let me just write that in. Okay, so hopefully you got yours also. So now this 40.7, that was the mean of my 3 numbers. What symbols do we use for the mean of the 3 numbers I picked? What's the symbol? Who remembers how to write the symbol down? The hint is you can't type it perfectly in the chat box, but you can explain what it is, or you can kind of say it literally. That's your hint. So what is the mean for my sample of 3 numbers? What's the symbol we use? Do you remember? Don't see anyone jumping in. I'll put it in slowly. It's X bar. Do you remember that? So X bar is a symbol we use for the sample mean. So a big piece of today is to make sure that you get all the symbols down, because we're gonna have a lot and they get confusing. I'm not trying to make them tricky. I'm using what everyone in the world uses, and that's X bar in this case. What symbol, this one's much easier, do we use for the standard deviation for the sample? This one you can type. That's a hint, very simply. So what symbol do we use? Put in the chat box. Very simple. Look at the chat box. I don't see anything yet. It's not X. Let's see. For the standard deviation, remember? Here's symbol for the sample standard deviation. Here's the hint. Sample, standard, simple.
S.
S. S. Okay, very important to know these symbols. And we've had these before. This is just a review, but reviews sometimes are hard. Okay, so far everything I've done, that could be, all this stuff you're supposed to know. Okay, now comes the new stuff. Now what I want you to do is put in the chat box the mean of your sample mean. And mine was 40.7. If you can put in the chat box, your sample means 38. Everyone's gonna have a different number. And round to 1 decimal is fine. And you should all have one. $37.2. Okay, I'll take it even though it's not possible. It turns out.
Hello. Sorry.
Okay. Yeah, you can't take three numbers. You can't take three numbers divided by 3 and get a 0.2 at the end. It turns out 27.3. That one's possible. What are the others? Okay, well, I think I'm going to keep going, even though, it's very important that you participate. Otherwise, you won't learn this stuff. Okay, and if you have questions on how to do something that I'm asking, please ask. That's the whole point of these webinars. Okay, so here's a sample. Here's some sample means. Okay, now we could have had a huge class. We could have had a lot more people in the class, and you would all have taken 3 of them, taken the average of 3 of them, and gotten a sample mean. Now, I have a list of numbers. Now, in statistics, whenever you have a list of numbers, you usually want to say, well, what are the statistics for that list? So what is the mean of the sample means? And I'm going to write the population mean of the sample means. Okay, so when I say population mean, that means what if I went and grabbed every possible combination of 3 of these 3 numbers from this list, listed the means of all those 3 numbers on my list, and then find the means of those. Any questions on that? All right, so the first thing is this is a population mean of sample means. The symbol we use for population mean is sigma. The symbol we use for sample means is X bar. Any questions on that? So if we want the population mean of sample means, then the way we write it is sigma sub X bar. And let me make this a lot bigger, because it's very important. So sigma sub X bar is I'm sorry, not sigma sub X bar. It's the population mean is mu sub X bar. Sorry about that. We'll get to the sigma sub X bar, so let me hold off on that. It's mu sub X bar because it's the population mean of all sample means. So it's mu sub X bar. Any questions on that? So if you have a list of all the sample means, we only have a few of them here, but you could list them all, and you take the mean of that list, that's mu sub X bar. Well, if we have a list of things, we could take the mean of that list. What else could we take of that list? What else could you take? Besides the mean of that list, what else would you be interested in?
Standard deviation.
The standard deviation of the list. So let's write this out. The standard deviation of all possible sample means is sigma sub x bar. Okay, maybe I'll even write the population standard deviation. That's what we're looking at. So we have this list of sample means. If you find the mean of that list, it's mu sub x bar. If you take the standard deviation of that list, that's sigma sub x bar. Any questions on that idea? Anyone lost? Okay, do you agree all of a sudden now we've got symbols that are a lot more complicated, but you are responsible for the symbols, how to write them, how to, at least write them in words if you can't type them, and also how to read them. Okay, so one thing is that you took the mean of your 3 from your sample. Is that a good guess? If all you know are the 3 numbers you grabbed and you don't know about the others, is the mean of your 3 numbers your best guess for the population mean? Or could you find a better guess? What do you think? So is the mean of the 3 numbers the best guess for the mean of all the numbers? What do you think? It's a quiet group today. Hmm? So is that the best guess or is it a better guess? Okay, if there's a better guess, what's the better guess? If all you have are the 3 numbers, you have no way of getting any other information other than those 3 numbers. How could you use those 3 numbers to get a better guess than your sample mean? I mean, should you take your sample mean and add 1 or something, or? So the idea is there is no better way. Okay, so if you want to find the population mean, then the sample mean is your best guess for the population mean. Any questions on that? So it really is the best guess. Okay, samples are good. Okay, let me give you okay, yeah. If you got to work at the same time, I understand. I don't multitask too, but make sure you do watch it later, especially when we get to the review. Okay, so if we consider the collection of all possible sample means, it's its own data with a very large sample size. Okay, when we have a data set, we can consider its distribution. The mean of the sample means is denoted by mu sub x bar. The standard deviation of all sample means is sigma sub x bar. It's also called the standard error. That's another way of kind of putting all that together, that sigma sub x bar. Let me put it in red because it's new. And that's called the standard error. Okay, and then we have a few things. One is the sampling distribution. Notice the ing here. The sampling distribution for a statistic for all samples of size n is the distribution of all possible sample statistics from sample size n. So a couple little definitions that we've talked about. And then it's time to answer the question that we had a bit. And that is, a statistic is an unbiased estimator for a parameter. if the mean of the sampling distribution for that statistic is equal to that parameter. Okay, so it's true that the mean of all possible sample means turns out to be the mean of the population. Let's think about the range. Okay, imagine taking a sample of, say, 10 randomly selected Americans, and you just measure how tall they are, all 10 of them. Then do you think the range of your 10 Americans that you found is a good guess for the range of all Americans? What do you think?
No.
No, it's a terrible guess, right? Because the range of all Americans is going to go from that little tiny infant that was just born premature, you know, not that many inches tall, just a handful of inches, to that, you know, super basketball player who's 7'9" or however tall you could be. And you're just not going to get those anywhere near those people if you randomly select 10 people, okay, or your likelihood of getting that. You can have a much smaller range. If you tried it 100 times, each time you can have a much smaller range, you know, almost certainly, than the range of all Americans. So if you think that you can grab 10 people, measure their heights, and say that the range is your best guess is the range of your 10 people, then that's just wrong. Do you agree? It'd be a terrible guess for the range of all Americans. Okay, because the range of all Americans is going to be more than 7 feet tall. And if you grab 10 people, you're almost never going to get more than 7 feet tall of range. Does that make sense? So the range is called a biased estimator because it's a really poor guess. Okay. The other big unbiased one is the sample proportion. So if you take the sample proportion, you do a yes/no survey question, then the average of all the possible sample proportions will be the population proportion. So the sample proportion is an unbiased estimator. So you're going to want to use your sample proportion as your best guess for the population proportion. Any questions on that idea? Okay, and in this class, mostly we're going to be looking at the mean and the proportion. We're going to kind of try to hope that we can guess at the population mean and the population proportion given our sample. And what we'll say is the sample mean is our best guess or an unbiased estimator for the population mean, and the sample proportion is our best guess for the population proportion. Any questions on that? Okay, so now what I want to do is I want to look at surveys. I want to look at samples. And I'm going to grab this, I call the discover the central limit theorem activity. I programmed it. And what this does is I can pick my distribution. Let's suppose that the population distribution was skewed left. And I can randomly select. Let's say I randomly select 36. Let's say I randomly select 36 from the skewed left distribution. And I take the average of those 36. And then I do it again and again and again and again and again and again. Then I look at the distribution of those averages. What do you think it's going to look like? Do you think it's going to be really skewed left? What do you think? Any thoughts? So again, I'm going to take 36 randomly selected from this data set that's skewed left, take the average, then do it again, do it again, do it again. And then I'm going to draw a histogram of those averages. Any guess on what the shape of the histogram might be? Do you think it's going to look like what I started with? It's just a guess. Better to guess than to not guess, by the way. Because if you don't guess, you probably won't remember. Okay. Yeah, let's take a look closer to the bell and we'll see. Okay, and of course I have the computer do it. I programmed this thing, but the computer does it. And isn't that beautiful? What does that look like? Okay, I had the computer do it 7,000 times. And then it drew a histogram of those 7,000 averages of sample size 36, and look what it looks like. The other thing is we started with 298 for our mean. Mu sub x bar is 298, random to the nearest whole number. So not only that, not only is this a beautiful normal shape, but the mean really doesn't change. The standard deviation, did it change?
Yes.
It changed a lot. It went way, way down. Okay. And let me do it again, but let's do it for 100 now and see what happens. So now we're going to grab a 100 of these from this data set, do it again and again, this time only 2,500 times. The computer takes a while to do these things. If you had to do this by hand, it would take years, so don't do it. And then we look at the standard deviation, which is about 9.7-ish. And notice our original was around 97. It got cut by a factor 10. Do you see that? Okay, now let me let you know it's not a coincidence that the square root of 100 is that factor of 10. Okay, so if I do 25, for example, still looks somewhat bell-shaped, not perfect. And notice now we got cut by around a factor of 5, which happens to be the square root of 25. If I do 2, does it look bell-shaped now? Does it look normal?
No.
Doesn't look normal at all. Okay. So if you have small sample sizes, you don't get this normal distribution. But with large sample sizes, we do. Okay. Notice that the mean is about the same. And the standard deviation did get cut a little bit. Okay. Not a huge amount, but it definitely got cut. And it got cut by a factor of the square root of 2, it turns out. So that is what the central limit theorem is all about. Okay. At least that's what it's about to say. Not what it's about used for, but it's what we're going to say. So let me read the central limit theorem before we apply it. And it says the following. The sampling distribution for sample means with samples of size n has mu sub x bar equals mu. So the average of all possible samples of size n is just equal to the average of the population. On the other hand, the standard error, the sampling distribution for all the standard deviation of the sampling distribution for all possible sample means of size n is equal to the standard deviation over the square root of n. All right, that's a big deal because if n is large, you have drastically reduced the standard deviation, the standard error. Okay, if n was 100, you've cut it by a factor of 10. And that's very important because remember, given the fact that mu sub x bar is mu, then if I grab an x bar and I have a very small standard error, then that x bar is going to be very likely to be close to mu, which means that our sample mean is going to be very likely to be close to the population mean if our sample size is large. Any questions on that? And the whole point of doing a survey is try to get an idea of the population given your sample. And what this says is that the larger the sample size, the better idea you get. Because your sample mean is going to be very close to the population mean if n is large. Okay, with very high likelihood. Okay, then number 2, if the population's distribution is normal, okay, which almost never happens, by the way, or, the or is the biggie, if the sample size is large. In our class, our definition of large is greater than 30. Where have you seen greater than 30 before? Somewhat recently. That should ring a big bell because I've tried to throw it in your brains. Yeah, project 1. The reason I had you do a sample size greater than 30 is so that in the real world, if you don't, you can't do statistics. It has no meaning because you don't know the distribution. But if the sample size is greater than 30, then the sampling distribution for the mean, notice it's mean, so quantitative data, which was like your project 1, is also approximately normal. So if we're approximately normal and we know the mean and standard deviation, then you can find probabilities. Okay, so I'm going to read this again. That's how important this is. Okay. On a scale of 1 to 10, with 1 being this is something you never have to worry about again, 10 being this is the most important thing that will ever happen in the entire course. What do you think this is? On a scale of 1 to 10. Yeah, this is a 10. I'm going to say it's the 10. Okay, this is the most important theorem. We're going to be using it every single week for the rest of the entire class. So the central limit theorem, in fact, maybe I'll do this for you. I'm going to make it bigger. That's how important it is. I'm going to make it shout out at you. So the central limit theorem is so important. I'm going to read it again. And that is a sampling distribution for sample means for sample size n has mu sub x bar equals mu, sigma sub x bar equals sigma over root n. And if the population's distribution is normal, not very likely, but very likely if your sample size is greater than 30, then the sampling distribution for the mean is also approximately normal. Any questions on the central limit theorem? Okay, let me run an example. Okay, and I'm gonna do a really easy question first. Very easy, if you understand it. Okay, if you put $10,000 in the bank, what's the probability that you're going to end up losing money after 1 year, given the fact all you do is you put money in the bank, you don't do anything other than wait a year, and then take that money out at the end of the year? What's the probability you're going to have less than 10,000? You're going to lose money at the end of the year, given the fact that you don't do anything else personally? It's a very easy question. Yeah, probability is 0. Okay, and by the way, I'm going to assume that America still exists at the end of the year, because America has to not exist for you to lose money. I'm not sure if you realize that, but that's part of the law. That's what they call FDIC insured. It means that your money is insured not to lose at the end of the year, okay, or the end of any time if it's in a bank. Okay, so is this the best investment in the world? Because, hey, you have a 0% chance of losing money. Do you think that's the very best thing you can do with your money in your bank? Okay, what's the problem with that? Why is it not the best thing to do? And the hint is right here. Yeah, it can earn interest. You can put it in a savings account, and it might earn like 0.1% interest, but it earns like hysterically low interest, right? You might end up with $10,010 or something like that. You're certainly not going to make anything. Does that make sense? Okay, so this may not be the best investment. Okay, this is a very good investment if your life depends on not losing money. Do you agree? If you will die if you lose money, then this is probably a good place to put it. Any questions on that? Okay, now comes the next question. The next one we talked about last week. And that is, suppose that you put $10,000 instead of into the bank, into a randomly selected stock. Okay. And by the way, this is particularly important for me today. Do you know why? Any guesses? Not I own shares, actually not Microsoft. Microsoft's a good guess, but Microsoft has all kinds of divorce issues right now. I'm just kidding. You've been reading the news, but he doesn't own anymore. Anyway, I actually bought stock today. Okay, pretty close to $10,000 worth. Not Microsoft, actually. I bought Airbnb. I won't get into the details on why, but it has a lot to do with this kind of stuff, though. And that's why I'm mentioning it. Okay, and I've made a lot of money already. Okay, we'll see what happens in the next year or so. Okay, so let's suppose that you put in the randomly selected stock. And let's suppose, okay, and this is something that, I've been doing stock for a long time. Let's suppose the mean return on stock is 9%. Okay, big difference than bank account, by the way. Okay, 9% is pretty good, isn't it? Right? If you're told that the mean return on stock is 9%, should you definitely invest in that instead of the bank account? Okay, the idea is not definitely, okay, because the standard deviation is around 20%. And if it's a big problem, if you lose money, then you no longer have a 0% chance of losing money at the end of the year. Does that make sense? So how do you find the probability that you're going to lose money? And we're going to make the assumption that stock returns are normally distributed. Okay. All right. That assumption doesn't quite hold, but it holds in the long term. In 1 year, it doesn't. In 20 years, it does. Just to let you know. So I'm making a few things up, but in a 20-year time, it's actually a pretty good assumption. Then what is the probability you're going to end up losing money? So if it's normally distributed, hopefully you all know how to do that. So the first thing is if you lose money, that means we're looking at the winnings being less than 0. Do you all agree with that? That's what losing means. It means you end up with negative amount of earnings. And we're given that X is normally distributed, because that's an assumption, with mean 0.09 and standard deviation 0.2. All right, now I'm hoping, how do you solve this problem? How do you solve the problem if you're given, if you want to find the probability that you're less than 0, your mean is 0.09 and standard deviation is 0.2? What do we have to do? I'm hoping you just know, because it's not that hard. The hint is it's very hard if all you have was pencil and paper. It's really hard, but you have more than pencil and paper. So how do you do it?
The Libra calculator?
Yeah, you use a calculator, in particular the normal distribution calculator. I'm going to, because again, we have a lot to do and I want to talk about the exam, I'm going to assume you know how to do that. I hope you do, because that could be on the exam, by the way, not this exact problem, but you're going to have to use the normal distribution calculator on the exam, which I'll be doing in a bit for something else. And I got a 33% chance of losing money. Okay, so the example I like to give is that it was a very long time ago when my daughter was born. I had some money, And I had to decide how to invest it because I wanted to put it into her college education account. So I wanted to make sure that I could pay for her tuition, okay, her education. So do you think I put it into a single stock? Do you think that would be a good thing? If there's a 30% chance of losing money and knowing I'm a horrible parent because I lost money and I can't afford, I gambled away her money basically. Okay. No, that would be awful. Okay. I didn't do that. Do you think the best thing to do would be to put it into the bank and then end up with maybe 11,000 after 18 years of waiting until she goes to college? Okay. And that's not the best thing either. So now let me talk about this chapter and how you use it. Okay. So now we have a new example. Okay. Suppose instead you put the $10,000 into a Dow Jones index fund. Now, if you don't know what that is, the Dow Jones is a collection of 30 stocks, not perfectly independent of each other, but over time, it's pretty good that way. And it's called the Dow Jones Index Fund. So instead of putting into a single stock, basically I took my money, put it into a fund at which all the people put in the fund, all that money goes into 30 different stocks. So now what is the probability of losing money? Okay, is it still 33%? Okay. And we'll find out in a moment or two. So first thing is we're going to assume that the Dow Jones is representative and the stocks are independent of each other. Okay. It's not the best assumption. If you want really good independent stocks, anyone know the business word for that in terms of what kind of investment you have to do to have them independent of each other? So statistically, we say independent. Do you know the word is in business? There's a word. It starts with a D. That's a hint. It's not a math word. It's a business word or an investment word. Yeah, it's diversified. Okay, so you put it into a diversified index fund, which is exactly what I did. I actually didn't do a Dow Jones. I did a diversified index fund. Okay, so that I can apply the central limit theorem, and let's see what happens. So now we have mu is equal to 0.09. We have sigma is equal to 0.20. Same, that's the same. All right, but now we have something very new, and that is X bar. It's not X anymore. It's the sample mean that matters. It's not the population mean, because it's not the individual. It's a sample mean, because I'm looking at the distribution of all sample means. By the central limit theorem, it is approximately normal. And mu sub X bar is equal to mu. So the 0.09 gets dropped over here to 0.09. Sigma sub X bar is sigma over the square root of n. So the sigma gets put here as the 0.20. N was 30, so we're dividing by root 30. Any questions on writing this down? Okay, so now I put this into my calculator, and 0.2 over root 30 is about 0.0365. So notice we've reduced the standard deviation by a lot. So instead of a 20% standard deviation, you now have a 3.7% standard deviation. Makes a huge difference in risk. Any questions on that idea? So now I want the probability that X bar is less than 0, because that was the question. Losing money means you're negative. So let's go to the normal distribution. So we have 0.09, 0.0365. Let's pop that in. So the mean was 0.09, standard deviation was 0.0365. Now, if I want the probability that x is less than 0, what's the low?
0.
Not quite.
Negative infinity.
Yeah, but we write negative a bunch of nines. You can't do infinity in the calculator. And what's the high?
0.
The high is 0. Because anything higher than 0 is not losing money. Do you agree? And just a note, because it's a continuous distribution, whether it's a less than 0 or less than or equal to 0, that gives you the same probability. So I can get away with 0, even though 0 technically is not less than 0, but it's whatever the border is all that matters. And then I hit calculate. What do you think? Now do you think it's worth the risk? Instead of a 33% chance, now it's less than 1% chance of losing money. Do you think that's worth the risk to get a 9% interest instead of a 0.1% interest? So do you think it's worth it? Yeah, this was definitely worth it. Okay. And this is what I did, by the way. So for her money, I put it into a diversified investment. And do you think this is a long time ago. She's at past college now. But do you think it turned out good or not? Do you think it turned out as expected? Okay, the answer is yes. Because in that amount of time, with that much stock, it's going to average out, and it's pretty much just about always going to be what is the expected value of the expected returns. So diversification makes it so that there's really no issue. Okay. On the other hand, it's not as much fun. Okay, but it wasn't all about fun to me. I want to make sure I could afford my daughter's education. So there's no gamble. If you like gambling, don't do a diversified investment. Put all your money in one shot, and then maybe you'll lose, maybe you'll win a lot. So really, you have to decide. Gambling means high standard deviation or high standard error if you can do more than one, and not gambling means low. Any questions on that? So that probability was 0.00, was it 6 or 7? I'll have to look. See what it rounded to. 7. Any questions? Any questions? All right, now that's a really small probability, worth it. So the central limit theorem is huge. What it basically does is it says if you take a sample that is large enough, then that sample is a very good representation of the population. Okay, that's really important. The sample mean is very likely to be very close to the population mean. And that is really important, not just for investments, but for everything that you do with samples. Okay, one quick question. Okay, what if instead we were good enough with our standard error being equal to 0.01? How big a sample size do you need now? Okay. So the idea here is we use the equation. Okay. And what we know, so we know is that sigma over root n, sigma was 0.2. Over the square root of n, we want that to be equal to 0.01. Any questions at all on this equation if we want to find how big a sample size we need. So the standard error is 0.01. Okay, this is the standard error formula, sigma over root n, and I set it equal to 0.01. So now there's a few choices. I'm going to multiply both sides by root n to get rid of the fractions. Sound reasonable? 0.2 is equal to 0.01 times the square root of n. How do I get rid of the 0.01?
Divide.
Yeah, divide by 0.01. Okay, 0.2, dividing by 0.01, by the way, turns out to be the same as multiplying by 100. So 0.2 divided by 0.01 turns out to be 20. So that tells you 20 is equal to the square root of n. How do I get rid of the square root?
Square.
I square both sides. And 20 squared is 400. So n equals 400. So I need a sample size of 400. Okay, if I want my standard error to be equal to 0.01. Any questions on that? Just a note, just for fun. I don't know if you ever looked at this kind of chart. You ever heard of the S&P 500? Okay, this is just a standard financial, website. S&P 500 is 500 different stocks. Now, if we assume that those stocks are independent of each other, which they're probably not, then if we assume they're independent of each other, then we're actually going to have a standard error less than 0.01, really tiny. Any questions on this example? Okay, so the next biggie is to talk about proportions. Many times you have a survey question that's a yes/no question, and you want to deal with it. So let me tell you the central limit theorem for proportions. So you could do the same idea. You take a sample, you ask the yes/no question, and then you can imagine taking all samples of that sample size. You can have a bunch of sample proportions, so a bunch of numbers listed. When you have a bunch of numbers listed, you could talk about their mean, and you could talk about their standard deviation. Any questions on that? So the distribution of all of those possible sample proportions is called the sampling distribution for sample proportions. It's the same idea, but now we're looking at proportions instead of sample means. Just the letters. P is the population proportion. We've seen that before. I'm not sure if we've seen that. I'm trying to remember if we've seen this guy or not. See this P, and there's a little hat on top of it? This is red P hat. So the good thing is mathematicians are not very creative in their talking, which makes life easier. You don't have to remember anything. It's P hat because it's got a hat on top of it. P hat is a sample proportion. And then another biggie that we use a lot in our class is Q is 1 minus P. So P is a proportion of yes answers. What do you think 1 minus P is? What will Q be? If P is a proportion of yes, yeah. 1 minus B is a proportion of no answers. Does that make sense? So you're often gonna look at Q and P. And here's the big central limit theorem for proportions. We're gonna use this a lot too. Okay, so again, today's central limit theorem day, it's the big theorem. We need all this stuff. And that is a sampling distribution for sample proportions for samples of size n is mu sub P hat equals P, which is another way of saying that the sample proportion is an unbiased estimator for the population proportion. because the mean of all possible sample proportions is the population proportion. Any questions on that? Okay, and then B is that the standard error, which is the standard deviation of the sampling distribution for sample proportions, is equal to the square root of PQ over N. Do you need to memorize this? Let's say for exam 2, where you will get tested on it. What do you think?
Yes.
Okay, no. You need to understand it, but you don't need to memorize it. So I want to remind you, because I can start talking about exam 1 too. It's the same. You get an index card, remember? So unless you got one of those perfect memories, go ahead, but you don't need to. Okay, put it on your index card. Okay, not for exam 1, because this won't be an exam 1, but you can put it on your little note card. Okay, so you don't have to memorize any formula in this class. What you do have to do is understand it. So if you don't understand what this means, that's not going to help to have it on an index card. Okay, or how to use it. So one thing that I do want you to know, though, if N is large, then what happens to the standard error if N gets really big? So if N gets big, what's going to happen to the standard error? So again, you have to memorize the formula, but you have to understand it. So if N is big, what's going to happen to this? Any thoughts? Yeah, lower. Okay, if you divide by a big number, you get a small number. Does that make sense? If you have $100 and you have to divide it evenly to 1,000 people, they don't get much, do they? If you only had to divide it evenly to 2 people, they get a lot of money. So the bigger N is, the smaller the standard error is. Any questions on that? Okay, then comes number 2. Number 2 is similar to number 2 of the central limit theorem for means, but there's a couple big differences, and a lot of people get confused because they don't even think about that they're in proportions if I ask you about proportions. So here's what it is. First, if NP, that's the predicted number of yes answers. So if you take the number of people you surveyed times the proportion who said yes, that's the number who said yes. And NQ, and that is the predicted number of no answers. And if both the number of yeses and the number of no's that you predict are larger than 5, none of this 30 stuff, larger than 5, then the sampling distribution is approximately normal. So I want to mention something that's very important. On exam 2, if I ask you a question about the sample size from a yes/no question, and you say, well, N is 40, and 40 is bigger than 30, so therefore the normal distribution, we have a normal distribution. What do you think is going to happen to you on the exam? For a survey question, it's a yes/no question, and I ask you, is the sample size big enough? And the sample size was 40, and you say 40 is bigger than 30, so yes. What do you think will happen? Any thoughts? Okay, let me tell you, you'll lose a lot of points. Okay, don't make that mistake. And I'll tell you, over a third of the class makes that mistake and loses points. So I'm telling you now, don't make that mistake. Don't be one of those losers. Be a winner. Okay, make sure you always look to see, is this a quantitative survey question or is it a yes/no survey question? If it's quantitative, you're comparing with 30. If it's yes/no, you're comparing with 5. Okay, and you're comparing NP and NQ with 5. Okay, so now I have the next example. I have an example of using the central limit theorem, and this is a real example. A star marker was pretty real too, by the way. That's what I like about this class, especially from now on, everything is real. I go right to CNN. So CNN says that most people satisfied with the Chauvin sorry if I pronounce it wrong. Chauvin, I don't know. Verdict. I read, I don't listen to the news, sorry. But there's a partisan divide. And I'm going to scroll a bit. Okay, but expectations for the way Black people and other racial and ethnic minorities are treated in American society following the verdict are mixed. Okay, where did it go? Always moves a bit. 53% say they're likely. Okay, again, I'm not going to read the whole article. It's almost so much time. But 53% say they're likely. Okay, that there'll be changes. Hopefully that means positive changes. So here's the question. And I'm going to write Black and other minorities. So here's a question I have for you. Okay. The question is, do we really have a majority? Well, a majority means over 50%, right? Okay. Well, if it wasn't a majority, let's do the highest case scenario of not being a majority is 50%. So if 50% of Americans expected changes in how Black and other minorities are treated, and let's say we did survey 1,004 people, okay, Americans, what's the probability that at least 53% of them will think the changes are likely? Any questions on the question? So I'll let you read this for a moment. Okay, and I want to let you know, this is what statistics is all about, is to be able to answer these kind of questions. And we're going to spend a lot of time on this in the next, the rest of the entire class, talking about how to interpret this sentence. Okay, and what it's used for and what to do with it and all kinds of things. So I wanted to give this as the example because it's what it's all about. All right, so the first thing is that if 50% expected changes, then that's P. That's the proportion of America who expect changes. So P equals 0.5. Q, what's Q? Q is easy, that's a hint.
0.5.
Yeah, 1 minus 0.5 is still 0.5, right? If you have 50% yeses, there's 50% no's. It won't always be the same, by the way. If P were 40%, Q would be 60%. So I don't want you to always think it's the same. It isn't. Okay, what's N?
Sample size.
I'm looking for it. I'm looking for a number. You don't have to remember the article. I've got it written there.
1,004.
Yep, 1,004. Okay, always good to write down kind of the key numbers and symbols. Okay, so we've got that. Now the next thing is we want to say, well, what is our distribution? Okay, well, first thing is that it's P hat P hat is our variable. That's our sample proportion. I think it's here. There it is. So P hat tilde N you know what? That tilde never works. I literally have to leave equation, make a tilde, put back the equation. Sorry about that. Tilde N And actually, let's make this bigger too so you can see it. So p hat tilde n. We know that mu sub p hat equals p, which is 0.5. And then sigma sub p hat is equal to the square root of the fraction p, which is 0.5, times 0.5, that's q, all over 1004. And that, by the way, is n 0.5, comma, and that's what, 0.5, square root of 0.5 squared over 1004. Let's just pop this in. Point 0.0158 about. Any questions on that? Okay, now we have our distribution. Let's write down, we want the probability. We want to find out what is the probability that our sample proportion so that's p hat is greater than 0.53. Any questions on how I've taken this sentence and turned it into a probability question with the central limit theorem? Okay, what do we do next? The hint is now we're at the point where you get tested on Friday, on Thursday or Saturday or Sunday. So what's the next step? So I just use the central limit theorem. Now it's time to go back. What do we do? If we know it's normally distributed, mean 0.5, standard deviation 0.0158, we want the probability that it's greater than 0.53. What's our next step? Yeah, put in the calculator. So our standard deviation is 0.0158. Our mean was 0.5. We want the probability that we're at least as big as 0.53. So the low is 0.53 and the high is, it's a bunch of nines. I mean, technically, I guess it's really 1 because you can't have a higher than 100% probability, but it actually won't make any difference whether you write 1 or 99999. So I'll put 9999. It's the same. Leave P blank. And it looks like about 3%. 0.028799, etc., or about 0.03. So there is a 3% chance of getting such a large, so, or larger proportion from the sample. Okay, I'm going to tell you, and this is going to come in a couple weeks, but the whole purpose is if you have a really small percent chance, then you say something's going on. And that's when you talk about how to deal with it. Okay, and that's in 2 weeks. We'll get into what to do from there. Okay, but I wanted to kind of show you the nuts and bolts of what we're going to be doing in 2 weeks, because this week is about the nuts and bolts. Any questions at all on this example? Okay, I'm going to kind of quickly go over the central limit theorem for sums. It's really not that big a deal, but let me remind you the central limit theorem for means again. So mu sub x bar is mu, okay? Okay, now the mean, another word for mean is average. Hopefully you all remember that. Sometimes it's not the average you're most interested in. Sometimes you're more interested in the total or the sum. Can you think of an example, a real life example, where the total is more important than the average? There's a lot of examples, especially in one particular field. Yeah, paycheck. I'm going to give a different money example. Yeah, lottery winnings, although you typically don't win a lot of times.
Real estate?
Real estate, also probably not. I'm going to say business where you're selling stuff. So you're a lot less interested in the average amount of money the customers spend than you are in the total amount of money you get at the end of the day. Does that make sense? So that is like the classic example where total is the biggie, because all you care about is how much money that comes into your cash register by the end of the day. You don't care about what you know, whether 10 people spent that or 50 people spent that. It's how much money you get. Does that make sense? And so that's the main example where sums happen. There are other examples too, but that's the biggest. That's the one everyone knows. So now the mean is the total divided by the sample size, right? Hopefully you all know that, right? Add them up and divide by n. So you can go backwards and say the total is the sample size times the mean. Does that make sense? Any questions on that? All right, so if I want to get the central limit theorem for totals, the good news is all I have to do is multiply by the sample size. So I'm going to go mu times n, and then sigma over root n times n. Any questions on the idea? Okay, so now I could state, which I just stated basically, the central limit theorem for sums. And that is a sampling distribution for sums from sample size n has mu sub x bar and mu, right? You just take the mean multiplied by sample size. And sigma sub x bar is sigma times the square root of n. That's a little algebra. If I take sigma over root n and then multiply by n, then n over root n tends to just be root n. And that's the old rationalizing the denominator stuff that happened in algebra. Okay, so that's a sampling distribution for totals or for sums. And then number two is exactly the same as what we had for the central limit theorem for means, and that is if the population's distribution is normal, if the sample size is large, greater than 30, then the sampling distribution for the sum is also normal. So nothing changed. Okay, the one thing I should note, let me put this in. The way we say this is sum. Who remembers a way of writing sum in math? What symbol do you use for sum? For if you're adding a bunch of things up, not just two things. If you don't remember, it's sigma, capital sigma. And it's confusing because lowercase sigma is the other one for standard deviation. Okay, I know small, make it bigger in a minute. So sigma tilde. Let's just make it big now. So sigma is the sum. tilde n. And then it's going to be n mu, comma, sigma times the square root of n. Okay, so this right here is all of the central limit theorem for sums in one little symbolic thing. But again, if you don't understand the symbols, that won't help. But if you want to remember the central limit theorem for sums and you like symbols, that's all you have to know. It tells you everything, all the information here. Any questions on this? Okay, central limit theorem is big. Don't take it lightly, but it will not be on the first exam. If you use the central limit theorem on the first exam, do you know what that means? It means you're totally lost and confused because it's not on it. If you use it, you made a mistake. Got it? Okay. But it's going to be on the homework due Sunday, and it's going to be on the next exam. It'll be on the final exam. It's going to be on every chapter after this week. So it is very important, but not for the first exam. So what I want to tell you now is a secret word. This time I remembered. You don't know how many. It took an hour, I think, of my time to get that secret word into the video because I forgot last time. Getting it all produced. But now I've got it. So the secret word, technically, I guess it's not a word. It's initials. What does CLT stand for?
Central limit theorem.
Exactly, central limit theorem. So I always try to make the secret word a main point that you probably wouldn't just randomly guess. If you just tried to grab a bunch of words, you'd probably put central in, you put limit in, you know, and might put sigma over root n in, I don't know. But CLT, maybe not. So CLT is the secret word. And hopefully you've got that. Write it down. Don't forget, because we're moving on. And now, we have our exam. So a lot of things to note is exam 1. I want to hit the syllabus, which I think is there. And I want to remind you all the different rules of the exam. We did talk about this on, the orientation day, but it's been a while. Okay. And there's no if. It will be done online, by the way. I was still way too hopeful that the whole world was going to get better, and sometimes I'm wrong. I was pretty sure it wasn't going to be. Fall, I think, is going to be better. So you're going to bring. Let's see. Let me fix this. I got the wrong. The wrong section. I wonder why. Where is the section? Oh, I lost it somewhere. Sorry about that. I wasn't in your class. They don't get 3 choices like you do. There we go. Okay, so students will be taking the exam using Proctorio. Okay, I hope you all took the Proctorio practice test so you know what you're getting at and you know your computer's going to work. It works on most computers, but not all. So if you haven't, you need to take that practice Proctorio test. Make sure it works before you take the exam. I do want to make a note, and you should write this down so you don't forget because it causes a lot of stress. If you open up the exam and it says that you need I think they call it ID or something like that, and you're supposed to type in that password ID, it meant that something went wrong with Proctorio slightly. And what you need to do is you need to refresh. Turn it off, turn it back on, and then it shouldn't ask you that. Okay, so there is no password to get into Proctorio. So if you're into Canvas and you click on the exam and it asks you for some kind of, number to put in, then just start over again. Okay, don't get all stressed out. Just turn it off, turn it back on, and then it usually works within 2 or 3 tries. Most of the time, the first try, it actually works, and you won't see it. But I want to mention that's the number one stress that happens at the very beginning. You have to have a webcam. Okay, and it has to be on. And I do let you know that how many people do you think have access to looking at you? In other words, how many people can have access to this video that's going to be on? Yeah, 1, and that's me. Okay, but most likely I won't even bother turning it on. Okay, what that is that if you're cheating, I usually can tell that you're cheating because the way you're writing is not the way you usually write, or it just doesn't fit in with the class or whatever. And then what I do is I go and watch the video. Okay, and those who don't cheat really don't have to worry about it. Okay, even if it says there's all these red flags, I can tell just by looking at the test. But then there's the backup is then I have the video for proof and all that if you're cheating. So don't cheat. Got it? So, and you don't have to worry about, whether your room is clean in the back. No one really cares. Even if you're cheating, I don't care if your room is clean. I care that you're cheating or not. Just let you know that. So don't worry about that. Okay. The other thing is you are not allowed to talk to any adults during the exam. And my definition of adult is the ancient definition, what I'm going to use, and that is post-pubescent. Okay, so like 13 and up, basically. Because if you have a 3-year-old and you need to tell them, yeah, you can go to the bathroom, you can go potty, that's fine. You can say that and do it, please. Don't torture your child. If you have a 16-year-old, tell them before the test, don't bother me, don't even talk to me, and they might listen. Does that make sense? And if you have a roommate, tell the roommate not to talk to you. Got it? Because you're not allowed to talk to any adults. So that's a biggie. You get a 3x5 note card, front and back. Okay, front and back. You can write anything you want on it. The very beginning of the test, you're going to pick up the note card. You're going to show it to the camera, front and back, and then you're going to put it down. And that way, the camera knows that you're using that note card. Any questions? So it's not an open book test, but you get that one note card. Is that clear? So formulas, that kind of stuff are good for the note card. Okay, so that's the main thing. Then you're going to open up the exam. Okay, the exam is a 2-hour exam. Okay, it closes after 2 hours. Don't take longer than that. There's no such thing as being able to do it late. It just turns off. So 2 hours, it's over. Got it? The only exceptions is if you have a disability that requires extra time, then I've been notified about it, but the problem is that I don't know what day you're taking it, and I have to set up that time for you so that the computer knows to give you your disability extra time. Does that make sense? So you send me an email saying when you want to start and end based on the extra time. If you get extra time, if you don't get extra time, you don't tell me anything. I don't need to know when you're taking it, but you have to take it either Thursday, Saturday, or Sunday. Okay. If you do get the extra time because of disability, 2 of the hours has to be while everyone's taking it. And so you can start earlier or later if you have a disability. So that's just a note about disabilities. Any questions on the rules? Huh?
May you repeat that part? You said 2 hours have to.
So if you don't have a disability that allows you extra time, you get 2 hours. So for example, if you take it on Thursday, the exam starts at 6 p.m. and it ends at 8 p.m. period. Not flexible. Okay, if you take it on Saturday, it starts at 8 a.m. and it ends at 10 a.m. And if you take it on Sunday, I believe it's 11 to 1. I can go down and double check, but I remember right. And when you go down, you can always find the exam this way. Okay. And yeah, Sunday is, yeah, 11 to 1 on Sunday because it says here. Any questions on the rules of the exam? Okay, so those are the rules. Let me tell you what to expect on the exam. So question number 1 is all it is you're signing your name off to say you're not going to cheat. And I will give you a point for that. And if you don't do number 1, you get a 0 on the exam. So it says, write your name below if you agree to not communicate with any adult and not use any other devices or materials for this exam that have not already been expressly allowed by your instructor. So you're allowed to have that note card. You're allowed to have, you're allowed to bring blank paper with you, but show it to Proctorio. Show the blank paper to Proctorio. And then obviously you're allowed to have a pencil and or pen if you want to write notes. But I do want to let you know, if you write stuff on the blank paper, you don't get credit for that writing. So you have to, so you really want to be typing in, you know, your thoughts and not writing it on paper. But some people need that paper. And that's it. That's all you're allowed. Okay, a glass of water is fine.
Will there be room to write in notes and things on the exam?
Yeah. So the exam, let's see. Maybe I'll go to one of my other sections exams. Yeah, don't get scared. This is going to be calculus, but then you get to look at what an exam looks like. So let me give you one of their quizzes. Just a minute. One more time. Yeah, in fact, let me not do theirs. Let me do the other section. Because theirs is actually more interesting. And then I'll show you what it's going to look like. Some of the exact stuff you're going to have to see. Okay, not the exact wording of questions, but what it's going to look like. Oh, shoot, wrong one. Sorry about that. One more try. That was Thursday quiz, chapter 6. Okay, so you're going to have a question like so. This was their quiz question they had last week. And then embedded in the question, do you see what you see? What are you looking at?
Calculator.
The calculator. The calculator will be directly embedded in the question when you need it. Got it? Okay, you're not allowed to open any other tabs. So I made sure that you have the calculator like right there for you. It's as convenient as it gets. So if you want to do a normal distribution, you just click normal probability, and then there you go. Okay, it says high, low, mean, standard deviation, P equal, you hit calculate. Okay, then down here is where you type out, you know, I found the high to be 3 and the low to be 2 and whatever. Got it? And then, and my answer was 0.3. Okay, whatever that might be. And that way you're kind of showing your work, you're showing your thoughts. Does that make sense?
Yeah, thank you.
And let me tell you how important it is to show your thoughts. Okay, let's suppose, and let's say the mean was 45 and the standard deviation. Let's make it not 45, let's make it 4. And the standard deviation was 6. And my answer was, let's say 0.48. Okay, and let's say your answer is wrong. Let's say instead of 0.48, let's say it was supposed to be 0.28. Okay, but all you really did is make a typo. If you had all this in there, you'll probably get like 8 or 9 out of 10 points. Does that make sense? If you don't have this in this, so all you have is 0.48, how many points do you think you'll get? Yeah, now I usually give a mercy point for typing something. I'll give you like 1 out of 10. Big difference between 1 out of 10 and 8 or 9 out of 10. Does that make sense? Okay, so, and no one's perfect. I mean, I make typos too. So the key to making sure that you get points, even if you do a typo, is that you write out what you're doing. Does that make sense? Okay, so does that help to see what the test looks like?
Very helpful. Thank you.
Yeah, so that's what your test is going to look like, except there's not going to be one. This only had one question because this was a quiz, not a test. I didn't want to show you the test because you're taking the test. So
Can
let
you
me show
go
you.
back to questions?
What's that?
Can you go back to questions or do it out of order?
Yeah, I think you can do it in any order you want. Yeah, it's not like you submit and then it's gone forever. You can always go back, but you can't go back after 2 hours. After 2 hours, it's over. Got it? All right, let me tell you what the next questions are. The first question you all better get right. You type in your name, okay? Okay, unless you're going to cheat and you don't want to sign your name, but then you get a 0. Okay, 2 through 7 are true false questions. Okay, those are not partial credit, by the way. True false, I can't give you, if you say true, I can't give you partial credit if it's false. So just note, they're not worth as many points per problem. That's another thing to note. Don't take a lot of time on them. Mostly easy know them or you don't, but don't leave them blank. Blank is a disaster. Okay, if you leave it blank, what do you think the probability is that you'll get it right if you left it blank?
0.
Good. Okay, if you have no idea what the answer is and you just guess like true, what do you think the probability you get it right is?
It's 50-50
And what do you think's better?
guessing.
Yeah, don't be stupid. Okay, don't leave a true false blank. Got it? Okay, it's the easiest way of getting at least 50%, but hopefully you won't just have to total guess. Hopefully you'll actually know why it's true or why it's false and you'll have the right answer. Okay, then 8, 9, and 10, they're multiple choice statistics ideas. So not quite true, false, or things where we've had lots of different types of different things and you have to pick from one. So what do you think I mean by that? What vocabulary kind of goes in groups? So these are kind of vocabulary stuff. Any thoughts? Especially earlier in the class, that's a hint. So it's been a while. Formulas, no, I don't test you on memorizing the formulas.
Like what the data is and the categories kind of that we were supposed to put things into.
Okay, yeah, so things like what type of data is it? And I can give you a bunch of words and you have to pick the right word.
Population and that kind of stuff.
Mm-hmm. I could also ask you things like, what's the sampling technique? Remember, we had a bunch of different sampling techniques. And then I give you, the list of all of them. You got to pick the right one. I could ask you, which statistic does this describe? Or which chart is this best for? If you want this, does that make sense? So it's more of the older stuff. Just let you know that. Okay, number 11 is finding and using statistics. Remember, statistics, they're the mean, the median, the Q1, Q3, the z-score. There's the maximum, the minimum. There are a lot of different statistics. So you should be able to find them and use them and understand them and interpret them. Does that make sense? If I give you data, you should know how to deal with it. Get the statistics and interpret it. Does that make sense? Okay, number 12, and you're going to see more than once, is a probability question. What chapters did we have probability questions?
3.
3, what else? How about 4? How about 5? How about 6? They all had probability questions, right? 4 was binomial, probably had binomial. 5 had uniform probabilities. 6 had normal probabilities. So this doesn't tell you a whole lot, but it is a probability question. Okay, number 13 has a paragraph, which I'm not telling you. And then it has some questions. Write down the probability distribution table for this situation. And then calculate the expected value and standard deviation for this situation. And then use a complete sentence to interpret this expected value. How do you think you can find good practice and good review for this?
In the practice questions in each chapter?
Okay, that's one, but there's better. Okay, if you don't remember, the discussion assignment. Okay, from week 3. Do you remember having to do that? You had to come up with a expected probability table, expected value, and then interpret. And I gave you a model. Do you remember doing that? In fact, let's look at part C. What are some of the words that must be in the answer to part C?
Most likely close to,
Keep going.
I forgot the third one.
There's a third and a fourth, by the way.
Average.
Average, and one more. Yeah, the one more is the first one, actually, but on the list. Many. Remember that? Okay, so you want to go back and review it. Okay, and I'm not just saying write those 4 words and it's all you have to write. I mean, you have to write a full sentence. But if you don't have all 4 of those words, then you'll lose points. Got it? Okay, and you're allowed a note card. There's no excuse. You know it's problem 13. You're allowed a note card. You know it's part C. You have the 4 words. You can put them on your note card and make sure you use them. Does that sound like I'm being mean, or does that sound fair? What do you think? If I
Fair.
say, okay, I will let you know that last quarter, over 50% of the students didn't have those 4 words on part C. I give this every time. And I don't know what else I can do other than, hey, you're going to lose points if you don't put those 4 words on part C. You get a note card. Okay, do it right. Okay, any questions on that? Okay, question 14 is read and describe a chart and understand the associated statistics. What are our 3 main charts?
Box plot,
Mm-hmm.
stem and leaf,
Histogram.
histogram.
And histogram, yeah. So we got the 3 charts, box, stem and leaf, and histogram. It's going to be, I'm not going to tell you which one, but one of those. You have to be able to understand it. And by the way, you can look at number 18, same thing. Okay, it has some extras too. But you need to understand it and be able to do stuff with it too. Okay, number 15 is a probability question, but I'm explicitly saying from chapter 3. Got it? So it's a probability question. It might be the hardest problem on the test because a lot of people have trouble with probability questions, but that doesn't mean you won't get it. But do your best, as I can tell you. Number 16 is a uniform distribution question. Okay, it's a very standard question. How should you study for this, for number 16? Any thoughts? Don't hear? Here's how you should do it. Do examples. So let me tell you how to find some examples. One is go back to the week 3 webinar and I did an example, and hear me say the example, hit pause before I start working it out and see if you can work it out. And then hit play and then watch me work it out and then fix anything that you didn't do right. And if you didn't do any of it right, start over again and try again. Does that make sense? And then try doing a bunch more. It's a very standard question. Okay. And hopefully you can make it happen. Okay, number 17 is a normal probability question. Okay, I do want to note, because this is a mistake I see students make a lot, 16 is uniform, 17 is normal. If you see the word uniform, do not go to the normal calculator. Okay, a lot of people make that mistake. Okay, whereas 17 is a normal probability question. So that means you do need to go to the normal calculator, which will be embedded in the problem, but you'll have to know how to do it. You should know how to find a probability, and you should know how to be given a probability or percentile and find the value of X. What's a good way of studying for number 17?
Doing more examples
Yeah, but what's the best ones to find?
in the discussion.
Yeah, the discussion, because the discussion is where you have to write things out. Okay, I mean, you can go to the old homeworks, but the problem with the homeworks is they only have you type in a number or something like that. The discussion, I made you write out all your work. So this helps you kind of practice and see what writing out work looks like. Does that make sense? So that's my big suggestion, is the discussions are the most helpful for practice. Okay, and then number 18, like I said, is another read a chart. And then based on the chart, find probabilities. Okay, and if you know how to read the chart and totally understand the chart, then the finding probabilities won't be too bad. Some are really easy, because there's like A, B, and C, I think, on this. And a couple of them are really easy, and one takes a little work, but it's not that bad. So that is what your test is going to look like. Any questions?
Larry, what about the calculator that like we need to use to square or square root or divide?
One more time. Sorry, you were chopping out.
Use the calculator to do like square root or divide or multiply, like
Okay, so let me show you. Let's see if I can find one that I did for these other guys. See, the problem is you guys see, the other class has twice a week quizzes. So I'm trying to think. Oh, I know where it is. Let's go to. That one, I think. Is that one right? I'll show you what it looks like. Oh, this has my answers too. I thought it was in here. Did I put it in there? Oh, I may not have put it in this one. Okay, there's a calculator. So you can't show it. I'm trying to find a way to show it to you, but I don't know if I can, because I can't show it to you without showing you the whole test, which I'm not going to do. But there's a calculator that I embed in that does that stuff. And it's actually a Desmos. See if I can find it. There we go. So do you see it? So if there's a calculator that's needed, I pop this one directly into the problem. And it's going to look like this. And if you want, just so if you can practice working on it, it's pretty easy to use. No one's ever complained about it. That's the good news. And that's why I keep using it. And I didn't program this one. So I put in the chat box a link to that. And Desmos is good. Desmos has a really nice calculator. They have a stats calculator, but I don't think it's as good as mine for the menus and all that. So that's why I made mine. Does that make sense? Okay, and I want to note that you can go back to any of your old assignments and practice. So for example, if you want to go practice chapter 5, you just click on that. And then you can practice problems. Any questions on that? So there's a lot of practice available. Okay, we're getting kind of late. This is later than I like to usually go, but I knew today was gonna be longer because I wanted to make sure that we had time for talking about the exam. And chapter 7 is an important chapter. This might be the longest of all of our webinars. So I apologize if I took longer than you think. But, you know, this is it. So I will let you know I do have office hours, you know, each day of the week. Tonight, Wednesday, Thursday, Friday. So I have regular office hours. I won't be on Zoom while you take the test. And you shouldn't be on Zoom either. One thing is it tends to crash the computer if you try to be on Zoom and Canvas with Proctorio at the same time. So you should only have the test screen open. Just a note. But I will be checking email when you're starting your test. Usually I check my email for the first 20 minutes because I figure if you're going to have problems getting into the test, it's going to be at the beginning. I don't stare at a screen for 2 hours while you're taking the test doing nothing. But I do check my email at least for that little bit of time at the beginning. So if you have questions, you can email me and let me know things are having issues. The issues, like I said, if it asks for some kind of ID, then it's just wrong. Try restarting. If you have, you should do it using Chrome, not Safari. So if you're a Mac user, better to use Chrome than Safari. Safari's got some problems with Proctorio, just a note. So Chrome is better. And I'm not as good with Macs as I am with PCs. So I can help, but I only so much. Haven't had a Mac in 25 years. So that's not my expertise. That doesn't mean you can't use one. But if your computer, you have that practice Proctorio quiz, and if you couldn't make that work, you need to get a computer. The college can give you one for free if you can get to the college. But you have to let me know so I can let them know. And they give it to you for the whole quarter. Okay, I'm going to stop the share and I'm going to stop the recording.